2014 New Jersey license plate has 3 digits followed by 3 letters. Okay, so 3 digits followed by 3 letters. The plates were not allowed to have the letters D, T, or X in the 4th position. So this one here cannot be a D, T, or X. So that'd be 23 different letters, right? Okay, 26 letters total minus those 3. What are the letters I, O, or Q in any position? So I, O, or Q here, take 3 more out of that in any position, so you have to take only 20 there. Take 3 letters out for that one. Take 3 letters out for that one. Okay, and the digits, there's 10 different digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay, so we want to multiply all those together to figure out how many different types of license plates they could have. 10 times 10 times 10 times 20 times 23 times 23 gives you over 10 million, 10.58 million. Okay, second problem says that there are 3-letter call signs. In 1912, the U.S. government began issuing licenses to radio stations. Each station was given a unique 3-letter call sign. By international agreement, the United States received rights to all call signs beginning with the letters W, N, and K. Radio stations in the western United States were given the signs starting with K, and the east were given the signs starting with W, like WMRA or WF, whatever. N was reserved for the Navy. How many 3-letter call signs like WGO start with the letter W? Okay, so there's 3 letters. First one has to be a W, so there's only one choice for that. There'd be 26 different letters for that, and 26 different letters for that. So there'd be a total of 676 radio stations that could be on the East Coast. Okay, part B. How many 3-letter call signs starting with W or K were available? Okay, so 3-letter, so this could be a W or a K, so there could be 2 different letters first, and then there's 26 different letters and 26 different letters. So 2 times 26 times 26 would be 1352 for the whole United States. Probably not enough. Okay, so the third one, by 1922, there were more applications for radio stations than licenses for the number with 3 letters. So they applied for and granted the sign WAAB. So part A says how many 4-letter signs starting with W are possible. Okay, so 4, the first one has to be a W. 26 different letters, 26 different letters, and 26 different letters would be same as 26 to the third, which would be 17576. So we went from 3 letters to 4 letters, and there are a whole lot more. Part B with W or K. So it could be W or a K, 1 of 26, 1 of 26, and 1 of 26, which is just double this, which would be 35152. So a little over 35,000 radio stations would be available. Okay, the next one. He has 10 science fiction novels on a shelf in his bedroom. How many different ways are there to arrange the books on a shelf? Okay, so you could do it 2 different ways. Okay, so the first way, there are 10 different books that I can have first. If I already have a book, there would be 9 that I could put there. If I have 2 books up, there'd be 8 there, and 7, and 6, and 5, and 4, and 3, and then 2, and then there'd be 1 left over. That's the same thing as 10 factorial. Okay, and 10 factorial comes up to be, there are 3628800. Over 3.6 million ways that he could arrange those on his shelf. A lot of different ways. Okay, at the beginning of class, Sharice's teacher makes a special offer. She will dismiss the class early if they can make all possible arrangements with 15 students in a single file line. So, should they take, how many different arrangements are there? And should the class take her up on that offer? So, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different people. So we could just start arranging these and moving people around. There'd be 15 times 14 times 13 and all the way down to 1, or it's the same thing as 15 factorial. And 15 factorial comes up to be let's see, that's there'll be 1.3 trillion ways of doing that. I don't think that they're going to get out of class early. I think it's going to be, they will not get out of class early. Okay, if you just think about that, if we take that, let's say it takes 2 seconds, okay, and let's say that if it takes 2 seconds for them to move and figure it out, which would take them longer, I'm sure, then say that's each class is an hour and a half. It would take them 40 million school years to do that. Anyway, side note. Okay. Next one is Declan has 100 songs on his MP3 player. He is going to run for a run and decide to listen to 8 songs while he runs. He decides to use MP3 random shuffle. How many different lists of 8 songs are possible? So 2 different ways of doing this. You can think of it, there's 8 songs, and there's 100 songs that he can choose from. And then if he already chose one, they're not repeating, so there would be 99 others, and then 98, and then 97, and 96, and 95, and 94, and 93. Okay, so you could do this a long way and multiply it all out. This would be the same as there's 100 songs, and we are choosing 8 of them. Okay, so 100 with the permutation of choosing 8. There are and that's 1, 2, 3, 4, 5. That many ways of choosing those songs. So he could go on a lot of different runs and have a different playlist each time. Okay. ATM passwords problem. They require a customer use for the ATM use 4 password to begin the transaction. How many different 4-digit words are there? Our passwords are there. So there's 4 digits. 1 of 10, 1 of 10, and 1 of 10. Okay. So that would be there are 10,000 different passwords that could be put in there. So if I steal your ATM card, I would guarantee if I put 10,000 different numbers in there, one of those 10,000 would be yours. Okay. So how many 4-digit passwords contain no 3s? So if it can't include a 3, that would only leave 9 numbers for each one. Okay, so 9 to the 4th is 65, 61. So quite a few less if I know there's not a 3 in it. And the last problem, suppose you roll a fair die. Roll a 5 fair 6-sided die, one after the other. So 1, 2, 3, 4. We're going to roll this 5 times. How many different outcomes are there? Well, the first one could have one of 6 numbers. The second die could have one of 6 numbers, 1 of 6, 1 of 6, 1 of 6. Okay, this would be the same as 6 to the 5th, which would be 7,776 different outcomes. How many of the outcomes from part A do all 5 die show the same number? Okay, well, they could all show a 1, all show a 2, all show a 3, all show a 4, or a 5, or a 6. So there's 6 different ways that they could all show the 5 number. Yeah, so there's 6 different ways that these 5 die could all be the same number. They could all be 1s, all be 2s, all be 3s, all be 4s, all be 5s, or all be 6s. So if you're thinking in probability that it's going to all the same number, this isn't part of the problem, but if you want to, there'd be 6 ways to have them all the same number out of the 7,776 different ways of getting it.